Thanks for the introduction. Good afternoon, everyone. First of all, I would like to thank the CECS for this wonderful opportunity. It is my great honor to give this short talk. My name is Patrick Son, a assistant professor from the Civil Engineering and Smart City Initiative. My topic today is UAV sensing systems for municipal solid waste landfill monitoring and water ponding issue detection. Nowadays, the idea of smart city is very popular, and we want to use new technologies to improve our daily living and our environment. In my view as a civil engineer, smart cities include the physical layers of buildings, infrastructures, and social layers of people and cyber layers of data. All the three layers are equally important for the city resilience. While behind this big picture, sensors and sensing systems are the critical components to connect the three layers. I built resilient infrastructure sensing and evaluation lab at UCF. My research lab at UCF focuses on providing sensing solutions in smart cities, such as municipal solid waste landfill monitoring for landfill in Hillsborough County, watershed mapping of our state forest at St. Cloud, and damage detection on structures near East Coast at Daytona Beach after hurricane. My lab is equipped with an industrial-grade UAV with sensing payload such as multispectrum sensing, thermal infrared imaging, LiDAR sensors, RGB photogrammetry sensor, and air quality sensor in order to plan UAV flight routes and process the collected remote sensing data. I'm also equipped with different software, such as UGCS planning tool, Metashape data construction tool, LP360 LiDAR data processing tool, and so on. Although UAV sensors and software provide a scalable platform for many civil engineering or smart city applications, my short presentation today will just cover on the municipal landfill cover inspection using data fusion. I will firstly start with landfill project background, and then I will go over objectives and method and some of the results. Living in a city, we generate solid waste every day, including food waste, yard waste, plastic waste, and so on. They are transported into municipal landfills, and every day it is growing. And the routine land management include manual elevation surveying, surface emission monitoring, or temperature monitoring. For example, by EPA regulations, we have to perform surface emission monitoring every 3 months to check hotspots of methane leakage. During the operations and management, there are some issues associated with landfill cover. One of them is water ponding issue, which may contain stagnant water after raining season or storm water events on top of landfill. And this topology depression might also cause the surface crack. This surface crack will cause water infiltration and landfill gas emission. And this landfill gas will contain greenhouse gases such as CH4, methane, and carbon dioxide, which is bad to our environment. So there is an urgent need for timely and economically efficient method for the spatial and temporal monitoring of the landfill surface emission, while the manual strategies or methods will take quite a few days for each of the time. And the detection of the cover issues, including uneven settlement, tension cracks, vegetation loss, leachate outbreaks, and water ponding will also require surveys and would benefit from an automated approach. So our team proposed a UAV-based surveying and inspection method. For example, before each of the flight, we use a drone equipped with LiDAR sensors so that we can get the digital surface emission model, or we get the digital elevation model so that we can know the topology features. And later, based on this topology feature, we design on purpose a meander shape route, which is showing on the figure at the bottom left, to mimic the same manual like surface emission monitoring. And we fly this drone only 2 or 3 meters above the landfill following the topology so that we can get this information about the hotspots of the landfill emission. We know that statistics analysis will be needed after the method will be developed. And the figure on the bottom right shows the emission signal or emission data before and after the Hurricane Ian. It's very interesting. Although we didn't detect any hotspots, but it is a very useful tool to be applied. In addition to this surface emission model, we also performed a landfill cover inspection by using a design protocol. We firstly designed UAV routes based on different emissions. For example, light emissions and air quality emissions, they have different routes. And later we get the remote sensing data, we pre-process and we generate it into different maps. And here we use 3 different maps for to get the information of the land cover health. For example, the first one is laser reflective intensity, and second one is from the DEM, we get the normal flow accumulation data, which can include the hydrology information. And the last one is from the multispectrum imaging. We get the water concentration that is staying within the vegetation. By fusing those 3 different modality of data together, we construct a water ponding index map. By using this map, we can automatically identify where are the potential ponding locations on the landfill without a human work on the landfill. And by directly comparing this data with ground truth data, which is collected by manual visual inspection and soil sampling by using the samples taken into UCF for the lab experiment, we get the soil moisture concentration. And next, after this project, I want to elaborate what are the research directions in my lab. The first one is environmental sensing and evaluation. This includes 2 parts. The first one is UAV-based remote sensing, which I have already covered. And the second part is deformation and strain measurement in structures, either from photogrammetry or coming from a MEMS-based or like material science-based sensors. And second big category of my research is human sensing by using computer vision. I have projects in doing human sensing in public open spaces, and I do have passenger origin destination pair detection in public transportation systems. I also invent sensors within a clean room by using MEMS technology. And the next 2 slides shows some of my current studies. Here I use multiple cameras to do a multiple vision sensing system to track the movement or deformation once we perform mechanical experiments. And next is a figure showing my study by inventing a thin film based sensor to track the strength development on top of a structure. Later, I want to include this part with my UAV technology so that we can provide a scalable solution to those structural engineers. In the end, I would like to thank my funding agencies, FDEP Hinckley Center, FDOT, and some support from UMich, which is from NSF and DDP. And I would like to thank UCF Office of Research, and I would like to thank CECS for providing my seed grant for performing my experiment and research in my first 1 year or 2. In the end, I would like to thank my collaborators, Dr. Artie, Dr. Zaki in transportation, Dr. Warren, Dr. Sadamani in water resources, Dr. Chalabas, Dr. Mackey, and Dr. Afsalakis in structural engineering, and Dr. Chen and Dr. Reinhardt in landfill studies by using UAV, and some of the external collaborators from UMich and Duke University. And that's pretty much of my presentation. Hope I didn't go past the time. Thank you very much.